Hello, everybody. Welcome. Today we are going to talk about the engine oil. It is a topic under the lubricants. So many people have been asking questions about the lubricants, the engine oil, especially the formulas, the viscosity, because there are so many types of engine oil out there. There are so many types, many brands, different formulas 5W, 30, 15W, 40, and so on. So people are getting mixed up. They don't know what is the difference. So they have been asking about it. So today we are going to throw some light on the topic itself. I'm Engineer Ken. I'm a petroleum and petrochemical engineer. I am an oil and gas consultant. My field of intervention is oil and gas, first of all the petroleum derivatives of the petroleum products, marketing and sales also. You can find some of my books on Amazon and so on. I've published a book named The Pathway to the Oil and Gas Business. I've published several books already. My field is the petroleum, the oil and gas itself. So the lubricants is manufactured from the oil and gas. So the lubricating oil, as I will use the right English, the lubricating oil comes from the refinery. So it is these are parts of the petroleum products. Okay, so it is still within the chapter of the petroleum product that you have the lubricating oil, and this lubricating oil will be characterized, or I mean, you have it in several types of lubricating oil. The oil that you are using on a car, on an engine car, is not the same you will use on a bike engine. Is not the same you use on a boat engine. It's not the same that you use on a ship engine. It's not the same that the airplane, the aeroplane, or a manufacturing a CM machine we use. So each equipment, each motor, each engine use a special type of oil. Before we get started, I would like to say, okay, this training will be subdivided into several parts, and today we will focus on the viscosity, because there is one of the the physical properties, I mean the physical and chemical properties of the oil, which actually differentiate the different kind of oil that you have on the market or in the industry. So one of the main factor is the viscosity, and today we will discuss a little bit about the viscosity. So the lecture today will be how understanding the viscosity itself, understanding the viscosity. I would like to say we give a special thank to Shell Company, that we have got some notes of from I mean some knowledge from Shell. So before I get started, I will say I'll give a special thank to them. Today we will discuss about the viscosity requirement. So understanding the viscosity requirement. Before the end of this lecture, you shall be able to define, at least to know what is the an oil viscosity, what is the different type of viscosity, how does it work, and also why is it important to use the viscosity recommended by the manufacturer of the engine that you are using. It doesn't depend whether it is an engine or it is a machine, a CM machine. In fact, I'm talking about all the moving parts, all the mechanical moving parts where you will need the lubrication, because there is no, I swear on that there is no machine that can work without lubrication, because the rotating parts will be touching each other. When the rotating parts are getting in touch, there is what is so called the waste. There are some waste that are being created, that you need the lubricant to carry it out. Also, the lubricant also has the one of the function of the lubricant is to cool down the engine. That's why I'm saying that all the mechanical equipments that you have that are actually having rotating parts must have a lubricating system. So it doesn't matter, and I will vow on that or any mechanical engineer will tell you that it doesn't matter on the machine that you are using, there must be a lubricating system. Okay, there must be a lubricating system. So let's keep the ball rolling. First of all, what is the viscosity? So you have heard about viscosity and so on. In fact, the viscosity is a measure of the oil's thickness and ability to flow at a certain temperature. Generally, the thicker the oil, the higher the viscosity. As I said, if you are measuring the ability to flow at a certain temperature, it means that the higher the temperature, the lower the viscosity, right? Because as you are heating the oil, it becomes lighter, and the when it is lighter, it means that it can easily flow. This is from the general, I would say, the common sense, because when you are heating something, right, it becomes lighter. Okay, so the higher the temperature, the lower the viscosity, and the thicker the oil, the higher the viscosity. There is what is so called the viscosity index, and most people who are into the oil and gas industry have heard about it. The viscosity index actually indicates how much the oil will thin when it is subjected to heat. You see, so actually in the lab, when you heat the oil, when you want to measure the viscosity index, you will heat the oil and measure the viscosity index according to a certain range that is given for the engineering matter. So the higher the index, the less an oil will thin when it is heated. So the higher the viscosity index, the less the oil will thin when it is heated. But don't focus on the viscosity index, provided few, I would say some of you are not from the engineering background. So let's focus on the viscosity, the definition of the viscosity I have given. So the ability of the oil to flow at a certain temperature. So if you have a temperature of 10 centigrade and the temperature of let's say 50 centigrade, at what is the viscosity at 10 centigrade will not be the same viscosity at 50 centigrade, or the viscosity at 20 degree Fahrenheit is not the same viscosity at 80 degree Fahrenheit. Please, if there are I mean, if there are some points, some missing point that you don't understand, feel free to ask your question, and don't wait for me to get to the end before you start asking your question. So as I am moving, feel free to stop me at any time and ask your question. Okay. Well, okay. So let's keep the but yeah. Okay, go ahead. Mm-hmm. Mm-hmm. No, I said the viscosity itself is the measure of how the oil flows, the ability of the oil to flow at the given temperature. Okay, but the viscosity index actually is we measure how the oil will thin, how the oil will I mean change the shape, that physical shape, that physical ability, to become stronger, or to have to add the thickness. Okay, to add a thickness when you when you heat up the oil. Okay, so let's focus on the definition of the viscosity. I don't know if you get the point. Okay, yeah. Okay, that's exactly where I wanted to go. You are saying there are you have seen some okay, okay, yeah. Okay, when you are out there, you will see that there are different types of oil. On each oil, you will see it is always written a certain formula, whether it is OW30, 5W30, 10W40, 15W40, 20W50. These are several types of formulas that you will see on the engine oil. Okay, that you will see on the engine oil. And each time that you see it, please, I want you to pay attention to that figure. I want you to pay attention to that formula before you buy your oil. I want you to really understand the meaning of that 5W30 you're buying, that 10W40 that you are buying. Don't just buy it because people told you, or just because the seller is telling you that buy this and go and use it. No, you have to understand the meaning. You have to understand what you are buying. Okay. And I was saying that when you see, I will take the case of 5W30. There is the W that you see actually is a contracted form of weather. It is the weather. So the weather as winter, as spring. Okay. So this 5W30, there are two figures. The 5, we have 30. Okay. And W is a letter. The W, I say, is stand for the weather or the winter. Okay, it's the same thing, but 5 is the viscosity at at very low temperature, and 30 is the viscosity at high temperature. Okay, so the viscosity that you have at 10W40, for example. Okay, when you have 10W40, it means that 10 is the viscosity at the viscosity of the oil, I mean, at low temperature, and 40 is the viscosity at high temperature. Okay, it means that when you pack your engine, or when you stop your machine, I mean, when you pack your engine and you come back maybe a week later, you want to start the car, you want to start it, the oil has cooled down, and this is the viscosity of the oil at that moment that it has cooled down. So the first figure defines the viscosity at low temperature, and the last figure defines the viscosity at higher temperature. Okay, feel free to ask your question. Okay, what is the oil viscosity? There is what is so called the SAE, the Society of Automotive Engineers. Okay, the Society of Automotive Engineers have defined several grades of lubricants, and it's most of the time written as SAE. You will see SAE 40, SAE 50. Okay, either you have SAE 40, SAE 15, you may have 5W 30, 5W 40, which you most of the time you will see, but 10W 40 and 15W 40, where the first figure, as I said, is related to the low temperature viscosity, and the last figure is the high temperature viscosity. The low temperature viscosity indicate how quickly an engine will crank in winter, and how well the oil will flow to lubricate critical engine parts at low temperature. And the lower the number, the more easy the engine will start in cold weather. So if you have two engine oil, you have 5W30, you have 10W30, it means that at a cold temperature, in winter, for example, where you have very cold temperature, an engine in normal condition, I mean, an engine with the 5W30 lubricating oil in the engine will start easier than an engine with the 10W40 engine oil. Okay, you get the point. So the lower the figure, the lower the number, the easier the engine will start. And the high temperature viscosity will, as I said, provide the thickness of the oil at high temperature. So pay attention to these specifications. Okay, and the larger the number, the higher the viscosity, which is very normal. I have explained it already, that if you have 5 and you have 10, it means that 10 is greater than 5. All right. Okay, I would like you to know that the SAE, the Society of Automotive Engineers classification, says nothing about the quality of the oil. And I really emphasize on this because on the market so many people will tell you that no, you are having this type of car, you are having this and that, you need to buy a 5W30 or you need to buy a 10W30. This is good quality of oil. This is maybe 15W40 is better than 5W30. No, please tell them that the SAE classification says nothing about the quality of the oil. Okay, it says nothing. It just defines the SAE classification. I mean, is based on the viscosity, so it is related to the viscosity. The quality of oil will be defined later within this training. So continue following the lecture. I mean, I will come on that. I will come back on that. Okay. And you will also know that the when you heat up the oil, the thickness will decrease. Okay, the thickness will decrease, and the amortiguing less when heated, providing more consistent oil pressure. The SAE 5W30 is equal to SAE 5W when cold, but SAE 30 when hot. I would like to. I'm always talking about cold temperature and hot temperature. No one ever asks what is cold temperature, what is high temperature. In general, when we talk about high temperature, it is 100 centigrade. Okay, high temperature is 100 centigrade, but cold temperature, most of the time, we are talking about the winter temperature, which can we can I would take I would just say 40-degree centigrade. So most of the time, let's consider 40-degree centigrade as the cold temperature during winter. But the high temperature you consider 100 centigrade. And when you are moving from 40 to 100 centigrade, you will notice that the oil will become thinner, and the thinner the oil, the lower the viscosity. Okay, the thinner the oil, the lower the viscosity. Let's keep the ball rolling. Is there any question so far? Feel free to ask your question. Okay.